Welcome to This Explainer. Today, we're diving into the virtual identity mystery. We're going to look at the invisible, detective-like mechanics of how the web actually recognizes you. It's this fascinating puzzle we solve dozens of times a day, usually without even realizing it.
Seriously, think about it for a second. When you log into your favorite site, how does it actually know it's you clicking around? We totally take it for granted that our personal profiles, our direct messages, and our saved settings are just magically waiting for us. But behind the screen, establishing your virtual identity is an incredibly complex, ongoing challenge for software engineers. Hooking your physical, flesh and blood self to a digital avatar is the ultimate technological mystery, and that's exactly what we're unraveling today.
Okay, to really grasp the gravity of the problem, we have to look at the absolute chaos that would break loose without it. I mean, imagine logging into your online bank, but instead of your checking account, you're randomly looking at a total stranger's financial data. Or picture an online store where you and someone halfway across the world are accidentally dropping items into the exact same virtual shopping basket. Yikes, right? Even worse, imagine a scenario where anyone at a university could just log into the system and edit their own grades. Absolute chaos. Identity is literally the critical glue holding our entire digital society together.
So this core problem presents a massive dilemma for the server. You can think of the server as a blindfolded detective. It receives a message from out in the void. Let's call the sender Client A, right? Then it receives another message. Is this second message also from Client A, or is it Client B maliciously pretending to be A to steal their info? The server has to figure this out instantly, and it's doing this millions of times a second.
And this brings us to a pretty shocking reality about the very foundation of the web. The protocols that govern our internet browsing, HTTP and HTTPS, are fundamentally amnesiac. They're what engineers call stateless protocols. Basically, to a stateless server, you are essentially a goldfish. Every single click you make is treated as a completely independent blank slate transaction. The server remembers absolutely nothing of your past actions. By default, the internet has zero memory of who you are from 1 millisecond to the next. So how do developers cure this amnesia? Well, by adding state. In a standard stateless transaction, your request is fulfilled and then immediately forgotten. But when we implement virtual identity, the identity provider gives you a token the moment you log in. From that point on, you're essentially handing the server an ID badge with every single click. This allows the stateful web server to consistently match you up with your stored session data in its database. It's like wearing a name tag at a massive, very forgetful party.
So now the server has a virtual identity for you. It can safely string your clicks together into a continuous session. Great. But, the virtual world doesn't exist in a vacuum. Service providers are absolutely desperate to link this virtual state to your actual physical identity in the real world.
And why are they so desperate? Because virtual actions have immense real-world impacts. If a service costs money, well, that payment has to come from a real human's bank account. If someone engages in highly inappropriate online behavior, like cyberstalking, there needs to be a way to inflict a penalty on the actual person sitting behind the keyboard. On the commercial side, many services are free because they're paid for by advertising. The more accurately they can tie your virtual habits to your real demographics, the more highly targeted their ads become. And of course, in educational settings, portals must be strictly restricted to genuinely enrolled students. The stakes of tying the virtual to the real are just massive.
But as we all know, real life is messy, and that makes tracking this identity incredibly complicated. Just consider a few everyday scenarios. What if two different people are using the exact same family computer to access a web service? Or what if you start a transaction on your work laptop and then try to finish it on your phone while commuting? How about a single person who needs to act in two different roles, like checking a private email account and a corporate account at the exact same time? And overarching all of this is the massive issue of usability. People absolutely refuse to type in a password every 2 minutes just to prove who they are. I mean, would you?
Section 1. The 3 prime suspects. How servers try to remember you.
Developers generally rely on 3 main strategies to solve this identity crisis. Think of them as the 3 prime suspects in our digital detective story. Let's interrogate them one by one. Our first suspect is the classic password. A username and password combination is great for database security, well, assuming you actually protect your password. But the usability? It's incredibly poor. Because the web is stateless, if passwords were the only mechanism we used, you would literally have to type your password every single time you clicked a link just to load the next web page. No way. Nobody would use the internet if it worked like that.
So enter the second suspect, cookies. To bypass the nightmare of constant logins, developers created cookies. These are just small pieces of code or text that the server stores directly on your computer's file system. They act as a little automated memory aid. Even if you restart your browser, the server reads the cookie and says, "Ah, right, I know this request. It's related to that login from earlier today." It automatically authenticates you behind the scenes.
Now, the traditional cookie has evolved massively over the years into various modern incarnations. We have features like local storage built right into your browser, JSON web tokens, and API keys. While the technical names differ, the underlying philosophy is exactly the same. Store something on the client side so they can securely authenticate with the server side without you lifting a finger.
But cookies and tokens definitely have a dark side. First off, they fail completely if you switch machines. If you log in on your phone, your laptop doesn't have that cookie, so it has no clue who you are. Second, they're vulnerable to theft. If a hacker intercepts your session cookie, they can impersonate you perfectly without ever knowing your actual password. And finally, because tracking cookies are heavily used for targeting advertisements, users have developed a deep distrust of them. We've all angrily clicked through those endless, highly annoying cookie consent banners online.
So, the crucial takeaway here is that passwords and cookies both have glaring blind spots. And that brings us to our third suspect, the IP address. If we can't easily identify the specific user without annoying them or risking stolen cookies, what if we just identify the machine they're using? Every device connected to the internet has an IP address, so the server can just look at where the request is coming from. Problem solved, right?
Well, it sounds foolproof, but IP tracking is fundamentally flawed as an identity tool. First, most people have dynamic IP addresses. If your home router restarts, your internet provider might just assign you a completely new IP. Second, if you switch from Wi-Fi to a cellular network, your IP changes instantly. Third, millions of people use proxies and VPNs specifically to hide their true IP address. And lastly, thanks to network address translation, a whole office building full of hundreds of different people might all appear to share the exact same IP address to the outside world. So yeah, IP addresses are definitely not the silver bullet.
Because the three prime suspects, passwords, cookies, and IPs, are all pretty flawed on their own, the tech world has rapidly evolved to finally solve the mystery. We're now seeing an exciting surge in modern alternatives that combine these ideas. We have biometrics, using thumbprints or face scans. We have multi-factor authentication, which requires proof from two completely different devices. We're seeing third-party logins, where you rely on giants like Google or Microsoft to verify your identity for other sites. And increasingly, we're moving towards passkeys, which aim to replace traditional passwords entirely with secure cryptographic keys stored right on your device.
Section 2. The ultimate trade-off. Balancing the scales of web design. What you should really take away from all this is that there is no magical one-size-fits-all solution. Developers must constantly mix and match these approaches, battling the ultimate trade-off: security versus usability. Make a system too secure and it becomes completely unusable. Make it too easy and you just invite hackers right in. So the next time you seamlessly open an app and it just knows you, take a quick second to appreciate the invisible dance of tokens, states, and biometric checks happening under the hood. And it leaves us with a pretty big question. As the stakes of our digital lives continue to skyrocket, how much everyday convenience are you truly willing to sacrifice for ultimate security online? Thanks for joining me on this explainer, and keep questioning the tech that powers your world.